everybody. Today's lesson is about similarity. We can see two similar rectangles. We can see here two similar triangles. We can see here two similar pentagons. Not only in the 2D shapes, even in the 3D shapes. We have here two similar cuboids and two similar pyramids, two similar cylinders, two similar cones, and so on. What is the definition of similarity? It is simply all dimensions are proportional. It means if we have this length is 10 centimeters and the scale factor is 2, what did you say? Scale factor? Yes, scale factor is 2. It means the baby rectangle, if you divide 10 by 2, it means its length will be 5 centimeters. And if the width of the rectangle here is 4 centimeters, it means the scale factor will be maintained for all dimensions. So the width here is 4, just divided by 2, so the width for the baby rectangle will be 2 centimeters. Okay, so here we say that the scale factor for this example only is 2. What about the area? Let's calculate it. Why not? Area of a rectangle equals length multiplied by width. Yes, area of a rectangle equals length multiplied by width. So if you multiply 10 by 4, which is 40 centimeters squared. What about the baby rectangle? Area is length multiplied by width, which is 5 multiplied by 2. It means it is 10 centimeters squared. Here we have to explain something very important. If the length is double the length and the width here is double the width here, this does not mean that the area is double the area, but the area is 4 times the baby rectangle. We calculated and you discovered by yourself that if the length is double the length and the width of the bigger rectangle is double the width of the baby rectangle, this does not mean that the area is also double the area. No, the area is 4 times the area of the baby rectangle. This is 40 centimeters squared and this is 10. So we discovered that area factor is scale factor what square. Area factor is scale factor but square. The same thing for all the 2D shapes. Suppose that this base is 9 centimeters and this base is 6 centimeters. It means that the scale factor in this case is 1.5. Scale factor is 9 over 6, which is 1.5. You tell me, Miss, 1.5 what, centimeters? No, it is unitless. 9 centimeters divided by 6 centimeters. If the units are cancelled out, it means that the scale factor is just a ratio. So the scale factor here is 1.5 without any units. This is about the length. This is about the base. What about the height? Okay, the perpendicular height, we drop it like that. So if the base of the Baba triangle is 1.5 times the base of the baby triangle, what about the height? If this is 4.5, it means this is 7 centimeters, for example. This will be 4.67 centimeters. So we maintain the same ratio, which is the scale factor. Scale factor means, now we have to define the scale factor. What is the scale factor? Scale factor is length over length, or width over width, or height over height, or perimeter over perimeter. All these are a ratio of centimeter to centimeter. The perimeter is measured in centimeters, but the area is measured in centimeters squared. So the main thing that we learned today, number one, similarity. It means that two similar shapes means there is proportionality of their sides, of their dimensions, even the height that it's inside the shape. Okay? For example, now we want to deal with the area factor. Area factor equals scale factor square. Area factor equals scale factor square. What about the volume factor? If you speak about volume, then let's speak about the 3D shapes. Here I have a cuboid, which is 8 centimeters by 3 centimeters by 5 centimeters. This is length, width, and height. 3D, 3 dimensions. If the scale factor is 2, it means that 8 divided by 2 is 4. 3 divided by 2 is 1.5. 5 divided by 2 is 2.5. Here, let's calculate the volume for the bigger one and the volume for the smaller one, and let's make the challenge now. What about the volume of the bigger cuboid? Volume equals length multiplied by width multiplied by height. Very soon we'll take mensuration. Volume equals length multiplied by width multiplied by height. You multiply 8 by 3, which is 24, multiplied by 5. 120 centimeter by centimeter by centimeter, you are finding volume in centimeter cube. What about the baby one? The baby volume is length multiplied by width multiplied by height. Calculators. It's 15 centimeters cubed. Let's discover the relation. If the length of the big one is 2 times the length of the smaller one, and the width of the bigger cuboid is 2 times, now scale factor is 2. I have to write it. Let's concentrate. Scale factor here is 2. Okay? So if the length of the bigger cuboid is twice the length of the smaller cuboid, and the width here is twice the width there, and the height here is twice the height there, don't think that the volume is just twice the volume. It's much more. How to know the ratio between volumes? Divide 120 divided by 15. It's 8. It's 8. What does this mean? We want to here to discover what is the volume factor. Volume factor is scale factor but cubed. Volume factor equals scale factor but cubed. Volume factor equals scale factor but cubed. Let's now concentrate about these relations and put them as a rule. Area factor equals scale factor but square. Volume factor for 3D shapes. Volume factor equals scale factor but cube. The same thing for the pyramid, the same thing for the cylinder, the same thing for the cone. Suppose that this volume of the cone is given, and the volume of the baby cone is also given. And we need to know the relation between the radii of the bases, for example, or the perpendicular heights, or the slant heights. Volume 1 is 750 centimeters cubed. And volume 2 is 6 centimeter cubed. When he gives you both volumes, it means he gave you the volume factor. Let's separate this question because this is the most important and indirect ideas here. Now we knew that the volume factor is the Baba volume divided by the baby volume. Volume big divided by volume small, which is 700. This is the volume what? Volume factor. It is 750 divided by 6. It is 125. What is the units of the volume factor? I told you before, it is unitless. Why? I'll convince you. 750 is measured in centimeter cubed. And this 6 is measured in centimeter cubed. Cut them out. So the volume factor will be 125, which is unitless. It means that the bigger volume is 125 times the smaller volume of the baby cone. So if I now give you a riddle, here I know that the radius of the baby cone radius is 2.1 centimeters. I need to find the radius of the bigger one. I put a question mark here. What is the relation between the volume factor and the scale factor? Read it here. Volume factor equals scale factor by cube. If we need to make the scale factor subject of the formula, what is the inverse function of cubing? Inverse function of cubing is the cubic root. So we'll write here, we have to find first the scale factor because we are dealing with radii now. A radius is a 1D. It's one dimension. Let's write the relation. Scale factor is the cubic root of the volume factor. What is the cubic root of 125? It is 5. It means that if you multiply the baby radius by 5, you will get the bigger radius. So now the radius, the bigger one, you just multiply 2.1 by what? By the scale factor. It is 2.1 multiplied by 5. 10.5 centimeter. Da-da-da. When we turn over, we'll find my workbook, which I collected from the Cambridge International Examinations, chapter-wise. This is the similarity topic. Question 1, zoom in. Mona made a model of a building using a scale of 1:20. Whenever you use the word model, you will not declare the word similarity, but we understand. A model building resembles the actual building, but the actual building is very big, and the model building, you can put it on your desk. It's exactly the same ratios. So the roof of the building had an area of 300 meters square. What's the meaning of the scale? This is the scale factor. It means that all the initial dimensions, you just, Mona, divide them by 20 to find the model height and the model width and the model length, all the model windows, the model doors. She divided all dimensions by 20. So You know here that the roof of the building, what does he mean the building? The big or the small? The building, the normal one, the initial one. So the initial building, the area of the roof is 300 meters square. If you didn't understand what does he mean, if you complete reading, you'll be sure of yourself. Calculate the area of the roof of the model in square meters. So now he wants the baby area. Let's write what did we understand. First of all, 1 is 20 is the scale factor, and 300 meters squared, it is the area of the bigger one. This is area big, is 300 meters squared, and he needs area small. I put here a question mark. Calculate the area of the roof of the model. It means he needs area small. Okay, what do you know about, you know the scale factor. So about area factor, let's write it. Area factor equals scale factor but square. And I have something which is shortcut to all this. You need to find what? The area of the baby one. So about the area, which is 300 meters squared, you need to make it bigger or smaller. I need to make it smaller because I need a smaller one, which is similar to the bigger one. So you just divide the 300 by 20. No, not by 20. Divide by 20 but square. Divide by 20 but square. Why but square? Because it's area factor. So I write here a rule that if you need to find area small, you just get area big and divide it by scale factor but square. So you divide the 300 meters squared, divide by 20 but squared. You will get 0.75 meter squared. Now there is no conversion. You have to concentrate because this is a trick you might face in this type of questions. Concentrate. There is here a meter squared and the 300 is also in meter squared, so no conversion. About part B, there is conversion. He is asking now, write your answer in square centimeters. In order to change from meter to centimeter, you remember the steps we took of conversion in video number 1, which is kilometer, meter, centimeter, 3 zeros, 2 zeros, 1 zero. Big to small, multiply, and small to big, divided by. From meter to centimeter, it is big to small. You multiply by 100. You tell me, Miss, it is not meter, it's area. It is meter squared. You want to convert it to centimeter squared. Multiply by 100, but squared. So this 0.75, you just multiply it by 100, but squared. It means you will move the decimal point 4 places. So you just multiply it by 100, but squared. The decimal point will move 4 places. It will be 7,500 centimeters squared. The next question, also, he didn't declare the word similarity, but he said the word parallel. Zoom in. The area of triangle APQ is 99 centimeters squared, and the area of triangle ABC is 11 centimeters squared. BC is parallel to PQ, and the length of PQ is 12 centimeters. Calculate the length of BC. Then he gave me two areas. Area of a triangle embedded inside another triangle. But in order to understand the question nicely, please split the baby triangle from the bigger triangle. When you split it and write all dimensions, all information on the baby triangle and Baba triangle, you will understand the relation. And remember, parallelism creates similarity. Parallelism creates similarity. We have to write this code, which is very important because he will not declare when he says that this side is parallel to the base, it means that baby triangle is similar to the Baba triangle. So let's write that parallelism creates similarity. So now there is a scale factor, which is the ratio that is common. It's maintained. The base of the Baba triangle over the base of the baby triangle is the same like the height of the Baba triangle over the height of the baby triangle. And this is the scale factor. And area factor is scale factor but square. Let's write the information. And let's write the letters first, because we need to concentrate. The main problem of students when they solve mathematical questions, that they need to concentrate. They didn't learn how to concentrate. Now I want to teach you how to concentrate. Write the letters on the baby triangle as shown on his diagram, and the Baba triangle, which is APQ. And then let's write the information for each one. The area of triangle APQ, it's the bigger one, it is 99 centimeters squared. The area of the smaller triangle ABC is 11. So this is the area of the smaller one, which is 11 centimeters squared. Without calculators, area factor is 9. How did you know it's 9? Just divided area big over area small. Now, let's write. This is area factor. What's the meaning of area factor? It is the ratio of areas. Area factor is area big divided by area small. As usual, the same question. What is the units of this 9? It is unitless. It means that the bigger area is 9 times the smaller area. Then we need to find the length of BC. I put a question mark of BC. Did he give me the length of the base PQ? Yes, the length of the base PQ is 12 centimeters. So you know the area factor, but you don't know the scale factor. I know it. The area of the scale factor, the scale factor, I know it from the area factor. What is the relation? I'll write it here in red. Area factor equals scale factor but square. If you need to find the inverse function of squaring, scale factor is the square root of the area factor, which is the square root of 9, which is 3. Now it's easy to find the missing base. The missing base is, what is the relation between this base and that base? What is the relation between this base and that base? The scale factor is 3. It means this 12, you divide it by 3, or you multiply it by 3. No, I should divide it by 3. You ask yourself, it just needs sense. You need to make the 12 smaller or bigger. If you need to make it bigger, multiply it by 3. It will be huge. It will be 36. Does not make sense. So if you need to make it smaller, you just divide it by 3. 12 divided by 3, it's 4. So you'll write here that BC is the length of PQ, which is 12 centimeters, divided by the scale factor, which is 3. And you write on the answer line, the answer is 4 centimeters.